Okay, we are going to solve now the second part of the question, because the first part was verify that z can be written as 1 minus square root of 3i, and we have verified here. We have verified, and then we are going to continue to write z in polar form. So this question was to write z in polar form. Write z in polar form. So we are going to write this in polar form. In polar form can be written like that: r cos of theta plus I sine of theta. Okay? The r stand for what? The r that we have there stand for the modulus. So we need to get the modulus. R is the modulus and the theta is the argument that we need to get. Now, how to get the modulus? Modulus, remember when we have z is equal to a plus bi, to get the modulus of z, you get the modulus of z, this is the modulus. So what we do a squared plus b squared, all inside of the square root. And this we give the modulus. And what is the modulus? The modulus here in the complex number, in the context of the complex number, the modulus is the distance from the point z to the origin of the axis. Okay? When we have, I give just an example. Okay? When we have the point, we have, if the point, for example, is here, if our z is there. So the modulus is the distance from here to there. This is the modulus. So distance from the origin of the axis to the point is the modulus. Now we are going to calculate the modulus. Now the modulus will be 1 squared plus minus square root of 3 squared. So this will give 1, and the square root of minus 3 is what? Many students, they make mistakes. So when you ask them, what is the square root of minus 3, for example? They will say, no. If you ask them, what is the square? What is the square? The square of minus 3. They say it's minus 9. No, it's wrong. It is wrong. It is not minus 9. It is plus 9. Okay? Because minus multiplied by minus, minus multiplied by minus is plus. So this here we give plus 3, and this we give 4, and this, the square root of 4 is 2. So we got the modulus is 2. Now the modulus is 2. The modulus here is 2. Okay, this is the modulus. As we have the modulus, we need to get the argument. So first, we need to know where is our point located. Where is the point, the complex number, is located. Now, we have to draw like that. So this is a real part. Real part is 1, and this is the imaginary part. It is negative, so it is the other. It is somewhere here. So it is somewhere there. Z is there. Z is there. And then if we need to get the angle, we need to get this angle. So this angle will be our argument. So when you go from here, round up to there. But using your calculator, if you use the calculator, and we put theta, our theta will be what? Because it is there, will be 360 degrees. Take away what we are going to take away tan reverse of minus square root of 3 over 1. Minus square root of 3 over 1. We do like that. So because it is there, as I say, so we turn around up to here. So it is 360 degrees. Take away this part. Okay, this part, we're going to get it by tan reverse of minus square root of 3 over 1. Okay, I'm going to take my calculator. Now, 360 minus, I'm going to enter this. Put a shift tan, and then minus square root of 3. So this will give what? This give me 60 degrees. So 60 degrees. So when using your calculator, you see that you're going to give minus 60. Minus 60 degrees. Why minus 60 degrees? Because when you go this side, when you go like that, it is clockwise. Clockwise is the sense for the clockwise is minus. Okay, minus sense. Minus sense. So clockwise is the minus sense in the diagram here. So, but if we go now from here to there, we do 360 degrees minus 60. So minus 60 degrees. This will give 300 degrees. 300 degrees. So our argument is 300 degrees that we have there. 300 degrees, we can convert 300 degrees in radian. 300 degrees in radian. So argument, as I say, our argument theta is 300 degrees. 300 degrees is what? So we know that pi, okay, pi is 180 degrees. Pi is 180 degrees. And pi over 6, so 180 degrees divided by 6 will give 30 degrees. 30 degrees multiplied by 10 will give 300. So I can write this 10 pi over 6. 10 pi over 6. 10 pi over 6. Okay, so this will give what? I can simplify. If I divide by 2, I get 5. This is by 2, I get what? I get 3. Okay, so our theta the argument is 5 pi over 3. Now, the question, remember the question has been asked to write this in polar form. So in polar form, I'm going to write in polar form. The modulus was 2, then cos of 5 pi over 3 plus I sine of 5 pi over 3. Finished. So this is what we have now in polar form. We have this in polar form. Okay, we have this in polar form. So now we are going to do the next part. Remember, the next part we have been asked to write Z3 using the Moivre theorem. So write this Z to the power 3, Z power 3, using the Moivre theorem. Okay, it is what we are going to do now. Now, using the Moivre theorem, to write Z to power 3 is what? We just put 2. Remember, it says like that, the Moivre theorem says R to the power n, R to the power n multiplied by cos of n theta plus I sine n theta. So this the Moivre theorem. Now to write Z with power 3, what am I going to do? I just replace modulus. The modulus was 2, and our n here is 3. I put 3 there. Here is 3 again. And then this was theta is 5 pi over 3. And here again I put 3 and then multiply by 5 pi over 3. So I put it like that. I put square bracket, the square bracket, put like that. Now, this 2 to the power 3, we give what? We give 8. So this is going to give 8. I'm going to write it here. Z3 is equal to 8. Okay, is equal to 8. Now, if I multiply here, we get cos 5 pi plus I sine of 5 pi. Now, we have it like that. So, if they said, write it in the form Z is equal to A plus B pi, now we need to write this in the form. So, now we are going to write this cos. We put the cos of multiplied by 180. So from here we're going to have 8. This we give minus 1. Okay. Be careful when you are using your calculator. Make sure that your calculator is in the mode, if you want to use radian, make sure that it is in the mode radian. Otherwise, you get a wrong answer. or if you want to work with degrees, so convert radians to degree before you use your calculator. Now here, the other part, if sine of this will give 0. So the other part will give 0. So we see that we give minus 8. So minus 8 plus 0i. And finished. Minus 8 plus 0i. So sometimes they can ask you, write Z3 in the simplest form. If they say write it in the simplest form, you just put Z, use Z is equal to minus 8, without writing the imaginary part, that is 0i. Okay, when they say write Z3, okay, if they say write Z3 in its simplest form, then we put just Z3 is equal to minus 8. But if they said, if the question was to write this in the form A plus BI, then it will be minus 8 plus 0i. We finish for today. Thank you.